All right, let's get rolling. So welcome everyone to Progress Next. I'm proud to be the first session of the day. Just know it can't get any worse than this. You know, I'm not the best speaker. I'm decent, but it's only going to go up from here, so don't be too disappointed. I'm always encouraged to see how many folks show up for these really specific talks like NativeScript. I know this is a technology that is relatively new to a lot of folks, so I'm glad to see you all here. Today, really what we're going to do is cover primarily NativeScript, but I also want to cover some of the other, what we call JavaScript native frameworks out there today, like React Native and Flutter to a certain extent. But hopefully I can provide a little clarity in this space, because I know it can be very confusing when you're presented with all these options and where you go for your mobile app development. So everyone knows you do not want to start a talk with a chart, but I'm going to start with a chart. And this is not really remotely to scale. It's not real data in any way, shape, or form, but it does kind of represent the growth in popularity of these JavaScript native frameworks today. It might help to put a hockey stick up here and maybe more appropriately demonstrate the growth of kind of where we're headed. First of all, a quick introduction to myself. My name is Rob Lauer. I manage the mobility developer relations team at Progress. So I work on the NativeScript team. I work on the Kinvey team. We're kind of all one big happy family here at Progress. Happy to be here today in front of all of you. And a quick level setting for the agenda. We're going to start by talking about kind of the rise of JavaScript native, what it means, who the big players are, why it's a thing, why you should even care. We're going to do a high-level introduction to NativeScript, React Native, and Flutter, again, to kind of a certain extent. Definitely look into some of the core concepts of NativeScript in particular, and kind of everything else as we have time. We'll do a little bit of a hello world, a little bit of debugging and such, but this is really a 101 level class, just so you all know. So starting with this existential question of why we are all here, we've all seen a slide like this 100 times before, right? We're trying to get a mobile experience on these devices. And yet today we live in a world of silos still, right? Or if we're developing for iOS, we're looking at Objective-C or Swift. On Android, it's Java or Kotlin. And on a Windows device, it's primarily .NET, right? What about cross-platform though? How can we achieve some kind of cross-platform utopia? Well, to achieve this, we have a lot of options today, and it's really overwhelming, even to me. We have the mobile web, and by mobile web, I mean, creating a mobile variant, responsive web, progressive web apps fit in here as well, really creating an experience that is tailor-made for a mobile browser. We also have hybrid, and by hybrid, I mean Apache Cordova or PhoneGap. The idea here is, in theory, to combine the best of web with the best of native to give you a native-like experience. We also have native, as I just mentioned, kind of building in silos. We also have what I call first generation cross-platform. Now these are cross-compiling solutions. So options like Accelerator Titanium or Xamarin, say, to take JavaScript or C# respectively and generate native code. And these are all still valid approaches. I'm not really knocking any of these in particular, but there are certain realities they all face when it comes to cross-platform. And as we will see today, I think the cool thing is that we can now accomplish really the best of all this using web technology, using these skills we've been honing for many years. But I am going to pick on mobile web just a tiny bit here, because when it comes to cross-platform apps, I do love the web. I love everything it represents. I love PWAs and hybrid to a certain extent. I was a hybrid developer for a few years, so I know some of the details. But there's always going to be features we need that the web can't provide, especially when it comes to native performance, native experience, and some native features. And if I love the web and I have these web skills, right, why not start with hybrid? And again, I mean Cordova or PhoneGap, or even Ionic Framework. You can loop that in here as well. Now, hybrid ideally lets you build a natively installable web app running on web technologies. And if we look at hybrid in particular, because I point this up because hybrid is really the reason that these JavaScript native frameworks exist. The hybrid model really preaches this reuse of 100% of your web skills, which is awesome, right? It also preaches the ability to leverage basically any native device feature, which also sounds great. So it can do everything, but the problem is our final result is often not perfect. It's kind of full of compromises, right? So hybrid can be great, but it has some compromises in terms of performance and features as well. So we strongly believe that hybrid has the right ideas, but just not quite the right implementation. Now, I don't mean to hate on hybrid too much here, but the issue is that customers agree. When you ask consumers how important mobile app performance is, we have about 84% of them saying it's either somewhat or very important. And this becomes even more important when you look at what they do after they've decided your app sucks. They either switch to a competitor or they get rid of it entirely, right? So these are really critical, critical variables to factor in. Now, in some ways, I could then posit that today, if we're developing a mobile app and we want to use our web skills, we kind of have this binary choice, right? We can go hybrid, and we can get fast to market, because with hybrid, we can develop for multiple platforms at once, in theory. But we're making compromises on that user experience, which, again, I'm proposing is really critically important today. Or we can go native, develop in silos, we get that native experience, but the problem is we're slow, right? We're developing for one platform at a time. Now, surprise, surprise, I'm proposing that today when it comes to using your web skills to create native mobile apps, it's not this binary choice. You can get the best of both worlds, and then we all celebrate in our own way, as the nerds that we are. So this is kind of where JavaScript native comes into play. Now, just what is JavaScript-driven native? Well, at its core, it is native UI. So native UI elements, no web views, native UI elements, native canvas, driven by JavaScript. Now, both React Native and NativeScript include kind of the same idea of a JavaScript engine in the app with some kind of bridge to native functionality. And they also let you share a certain amount of code across platforms. I do want to really touch on really briefly kind of some of the other players in the space today. The big three are on the top, and the two on the bottom are kind of becoming a little less relevant these days. I do want to mention them though, because Fuse Tools is a product out of a startup in Scandinavia. They were very design focused. I say were because they're kind of pivoting out of this space and becoming more of a consultancy. Weeks is a product from Alibaba. It was initially a big player in the Vue.js space, but now NativeScript now supports Vue.js, so we're kind of edging them out to a certain extent. Flutter I mentioned here because Flutter is really gaining popularity. The problem I have with Flutter, it's a Google product, so by default it becomes relatively popular because of the Google name. But the problem for me with Flutter is that you're using Dart, not JavaScript. Now, Dart is certainly it's relatively easy to learn if you know JavaScript, but I'm kind of disqualifying it from this talk. It's kind of convenient, but it's not JavaScript, so there you go. But let's focus on, to me, the two big players in this exact space, that being NativeScript and React Native. Now, again, they both basically work the same way. So you write JavaScript, it runs in a JavaScript VM on the device using native UI. It's not cross-compile. You're not compiling to native bytecode. It's JavaScript literally running in a VM on the device. I would say one of the biggest differences between the two is that NativeScript is focused on writing once by default and deploying to multiple platforms, whereas React Native is more focused on learning how to do something once and then writing for distinct platforms. You are still sharing some code with React Native, but not as much with NativeScript. Some other quick differences. Plugins with NativeScript are written with JavaScript or TypeScript, so plugins meaning to extend that framework into other native device features. With React Native, you have to use native code. With NativeScript, you can use a variety of frameworks. So today we support out of the box Angular, we support Vue.js, we just actually recently announced official support for Vue.js. You can also just write in plain JavaScript or plain TypeScript if you are a purist like me. With React Native, you are quote-unquote limited to React. React's obviously a very popular framework, so if you're a React developer, go to town. Interestingly enough, with NativeScript, there are two brand new community projects to bring React support to NativeScript, along with a new up-and-coming framework called Svelte. Svelte is usually, I would normally kind of discount this immediately because, yet another JavaScript framework. But I would take some time to look it up. It's kind of off topic, but the syntax is really terse and really, I think, pretty easy to understand. So this is kind of a topic to keep in mind going forward. What else? NativeScript provides 100% access, day zero access to any API on any device. Now this means this fall when iOS 13 comes out, on that first day you have access to all these new APIs out of the box. And this is one of the probably the single biggest reason people come to NativeScript versus React Native. With React Native, there is a bit of a delay here. You do have to wait for these native modules to get written to access all these device features. NativeScript, just as a quick mention, this is really kind of a nitpicky thing. NativeScript is single-threaded. Everything runs on the UI thread. I put an asterisk on there because there is the concept of workers. You can spin up worker processes with NativeScript. With React Native, there's separate UI and JavaScript threads. Now, you could get 100 NativeScript and 100 React Native developers in the same room, and they could, argue to the end of the day which one's better. At the end of the day, the performance between the two frameworks is remarkably similar. You're not going to notice there may be edge cases here and there, but you're not going to notice a big difference. So I'm always asked, obviously I'm incredibly biased here, but which one would I choose? To me, it comes down to frameworks, right? If you're an Angular or Vue developer, or you just want to write with plain JavaScript, choose NativeScript. If you're a React developer, I'm not going to talk you into switching frameworks just for a mobile library, mobile framework like this. So if you're a React developer, use React Native. Then it becomes kind of a progress versus Facebook kind of thing. Facebook, much bigger company, but the cool thing about NativeScript, from my perspective at least, is that we are really a critical component of Progress's mobility strategy going forward. NativeScript's not going anywhere. Facebook, on the other hand, does not have the best open source record. They seem to be doing a pretty good job with React Native. However, they have killed open source projects in the past. Not to spread any FUD about the Facebook or anything, but just know that NativeScript is really a critical component of our strategy going forward. They are both very similarly licensed. NativeScript with Apache 2, very permissive, business-friendly license. React Native, same thing, MIT, very, very similar license to React Native, to NativeScript. And finally, NativeScript, again, it's a critical component of Progress's mobility strategy, especially when it comes to Kinvey. It's really a core component of the Kinvey platform. So going forward, let's focus on NativeScript in particular. What do we get out of NativeScript? We do get this fast to market, right? We are sharing code across platforms out of the box, so we get this generated code for iOS and Android from one shared code base. We also are reusing existing, I'm going to switch my thing here. Reusing existing skills and teams, right? So we're using our web skills, we're using our web teams to develop these apps, as we'll see in a little bit. And we're also reusing existing libraries. So we can leverage JavaScript libraries from NPM. We can take CocoaPods, Android jars, plug them into our app, and they just work. And in terms of best experience, right, this is native UI. Again, there's no web views involved here, so we're getting that native performance. Again, getting that full access to device APIs. I'm probably going to repeat myself, but it's kind of a big thing to us. And this does mean immediate access to new OS features. Now, let me get into a bit of an introduction to NativeScript. Oh, this is my cue to drink some water. So I'll let you find the joke there. So let's talk about just a brief history of NativeScript really quickly so you know where we're coming from. We started back in like 2014, 2015, kind of the early days, a lot of core engineering, our initial product launch. I think the earliest ideas may have come back in 2013 even on this, so it's been around for a while. 2016 to 17 was very focused on product maturity. So we really took our time to make this a production-ready product before we started kind of doing some mass promotion back in kind of the 2017, 2018 phase. Now we're very focused on extending NativeScript functionality. And when I say extending it, I mean extending internally at Progress, again, through Progress Kinvey, as well as extending externally via a variety of resources, marketplaces, plugins, and templates, and all this kind of stuff. So that's kind of where we're at today. And in terms of popularity, we've been growing dramatically year over year. I think we had about 3 million plus downloads on NPM last year. And when you compare this, I mean, NPM downloads are not the best metric. They're one of the few public metrics we can use to compare us to some of our competitors like Ionic and React Native. You can see here that kind of the key trend here, at least, is that React Native and NativeScript are really eating into Ionic's overall market share. So people are seeing the benefits of these native possibilities and adjusting their workflows accordingly. And I realized I forgot to set up my sound on my device, but I had some cute little funny kid videos here, but we're gonna have to just skip over them. I'm sorry, but really these are like, I brought some neighborhood kids over and we all had them talk about NativeScript. You have to just trust me that they're hilarious. So let's focus on what NativeScript is. In case it isn't obvious, of course, it is a free and open source framework. You're creating native apps, truly native apps for both iOS and Android at the same time. I want to be very triply clear about that. You're using your web skills like JavaScript, CSS, TypeScript, and so on. We're also using popular frameworks and libraries like Angular, Vue, NPM, and such. So now that you have kind of a generically high-level overview of what NativeScript is, I do want to talk about the NativeScript difference. And you know what? Let's see how loud I can make this. What's the NativeScript difference?
I have no idea what that is.
I don't know. I don't think you heard that. So this is my son. I really wanted to kind of like, I talk about NativeScript at home a bit, and I really wanted him to tell us what he could tell me about NativeScript. He has no idea. It's really, I have a lot of work to do at home. It's kind of embarrassing, but you know, as technologists, it's good for us to really invest time in our children, but for me, it's not paying off. But what I want to do is really focus on some real key differences here. And the first is that we're focused on a very rich, animated, no compromise UI. So we feel apps should look good, feel good, and really be fun to develop, especially for web developers. So we're very focused on the web developer. Again, how many times have I said this? It's 3 times now. We're very focused on accessing 100% of those iOS and Android device APIs out of the box. And one thing that I'm going to talk about a bit today, and there's more talks about this later on, is about code reusability. So what you're seeing here is somebody taking a NativeScript app and actually developing not for iOS and Android, but also for web. So there is a code sharing story with the web here as well. So one way I like to kind of visualize this is thinking of the traditional MVC pattern of app development. When you take advantage of NativeScript code sharing, and I hope you can see that well enough, effectively what you're doing is you're getting rid of these extra models and controllers and one of the view layers especially. So we start talking about eliminating more than half of the layers of code that we're writing and sharing the models and controllers across all 3 platforms. The view layers are always going to be different, right? Because the web view layer is always going to be different from native mobile. And again, we're using existing native libraries. I want to kind of double down on this because this does mean you can grab CocoaPods that are freely available, plug them into your app, and they will just work. And same with Android jars. Same with most JavaScript libraries that you'll find on NPM. I will qualify this by saying you can't just plug jQuery into your app and have it work. There is no such thing as a DOM in NativeScript land. So anything that doesn't have a dependency on a DOM will work just fine. So libraries like Moment.js or other popular handlebars or those utility libraries, those will all work just fine. So let me get into a little briefly how NativeScript works, because for me, it is a lot of magic. I'm kind of an idiot, so I'm provided slides like this from engineering and our product team, and it's like, to me, it's like purposefully confusing to make it look like I know what I'm talking about. But for me, I think I always have an easier time understanding technology when I start looking at code. So if I were going to be writing NativeScript compatible code for Android, it might look something like this. Now, I'll give your brain a second to kind of parse this because it is JavaScript code instantiating a Java Android text format time object, calling the set method, logging the return value of the format method, and which turns out to be that string. Okay, that's all right. Probably kind of makes sense to you. Similar thing on iOS. So this JavaScript code instantiates the Objective-C UI alert view class, sets that message property, then calls the add button with title and show methods. And so when you run that, you get that native alert. All right, again, that's kind of cool in its own way. One nice thing here is that these methods that we saw in the previous slide, they map directly to the UI alert view docs from Apple, makes our development process a little bit easier. And again, all this code is running directly on the VMs on the devices. So with Android, it's running in V8. With iOS, it's running in JavaScript Core. As a side note here, the team is actively looking at porting V8 to iOS as well to have one JavaScript engine that we're worried about going forward, but that's for another day. However, we get to this point where like, why on earth would I want to write JavaScript that looks like Objective-C? That's like the worst of both worlds. It's a total nightmare. I point that out because you can do it, not that you should do it. Instead, we want to focus on the NativeScript module layer. Now, these are effectively abstractions on top of native APIs. So they provide a unified API across all these native features that you can access. An easy way for me, again, to look at it is to think about it is to look at code. So a good example is the file module in NativeScript. So we write a couple lines of JavaScript, quite simple, that map directly to these this native code, and this is all handled by the JavaScript runtime for us. Now, if I'm going to summarize everything I just talked about, we can really dumb down that initial diagram into something like that even I can understand. So what we're doing is we're writing application code on the top, right? And 99% of that code, if not 100%, is going to be coded against those NativeScript modules, right? Those cross-platform APIs. On the off chance that you need to access an API that's not available there, you can code directly against the NativeScript runtime. And that's where we get into writing that Objective-C-ified JavaScript. It's ugly, but it works. People do it. At the end of the day, the NativeScript runtime is going to gather all that code, spit out magically native iOS and Android apps for us. Now, if I were you, this is all new to me. It probably will help us all kind of gel if we look at these concepts in a little more detail and see pragmatically how we use them to create mobile apps. So when we put it all together, there's three components here. There's the markup. This is the native UI markup. So we have native UI elements that map directly to those UI elements provided on iOS and Android. And we'll look at those more in a little bit. Again, of course, we're using JavaScript as kind of the code behind, the engine of the app. And we actually use CSS to style the app. And I'll get into that more in a bit. So those three components are really going to make up your app. And again, I'm going to be doubly, triply clear on this. With NativeScript, you do have a choice in your architecture. You can use the built-in MVVM pattern available with the plain JavaScript, plain TypeScript methodology. You absolutely can use Angular. We've been supporting Angular for, 3-4 years now, and Vue within the last year. So we have a lot of choices for you out of the box. And oh, here he is again. Let's see if I can.
Jerry, what would you choose between Angular, Vue, or plain vanilla JavaScript?
I don't know. I'll just guess Angular.
All right. I don't know if you could hear that, but I asked him which framework he would choose. He chose Angular, which, yeah, it's a good choice. We've been supporting Angular for a long time. So let's see how some of these concepts come together pragmatically. And when I'm going to start a new project, a net new project with NativeScript, well, the first thing I'm going to do is I'm going to install NativeScript. It's available on NPM. Just run npm install like we do for 100 million other things. Takes a few minutes to download all the dependencies and all that. We're going to use the TNS command to say TNS create app name. TNS stands for Telerik NativeScript. This is a holdover to our pre-acquisition days before Progress acquired us. That's not going to change anytime soon. We're going to keep TNS, even though it's a little bit confusing. We're going to navigate into that Hello World directory, whatever project name we created, and then we're going to say TNS preview. TNS preview provides us a dependency-free way of running our app as quickly as possible on our device. So if I run this command, I don't have to install, I don't have to have Xcode installed, I don't have to have the Android SDK installed locally. I can get up and running really quickly. Now, when we get into more serious app development, we're going to want that Android SDK installed. We're going to want Xcode installed if we're on a Mac. If we're on a Windows machine, I'll tell you about other options as well. So this is just a really quick way to get you up and running. When you bootstrap an app for the first time, I just wanted to kind of clarify the project structure a little bit. This is an example of a plain JavaScript version of an app. And just to kind of clarify what some of these files are, let's highlight this section here for a second. These three files comprise one page or one view of your app. So the main page XML, this is your UI layer. This is just your HTML-like view of your app. Main page JS is the JavaScript that's going to power that view. And we can optionally have a main page CSS, which is going to provide the styling for just that view. You notice there's an app.css file as well that provides global styling for the entire app. So we can really break things up, and I'll talk about some of this file structure in a little more detail in a little bit. If anybody here is a Visual Studio, former .NET developer, I'm a former .NET developer, used Visual Studio for many, many years. For me, when I was initially thinking about this, I was focused more on how the JavaScript file is like the code behind, right? Powering that native UI element. So really, if we were gonna nest these files, it makes a little more sense for me to think about how those three kind of roll up into one page or one view. So with all that being said, I'm actually gonna switch over and do somewhat of a live demo here in the NativeScript playground. So let's pop open this bad boy. And we're going to head to play.native. Actually, I'm going to do incognito so we see the experience from. Oops. I can't type and talk at the same time. I'm just going to warn you that. So the NativeScript playground is a completely, again, similar to TNS Preview. It's a dependency-free way of getting up and running. Even more so, because I don't even have to install NativeScript locally to get this running. What I'm doing is accessing this complete development environment in a browser. Totally free to use, don't even have to sign up or anything. When we get started, we have a choice between frameworks to get going. I can start with Angular, I can start with Vue, I can start with TypeScript or JavaScript. I'm gonna stick with TypeScript. And the first thing we're presented with is a QR code. Now I'm gonna use my device to scan this QR code, and it's going to prompt me to install an app from the iOS App Store. We have a preview app on the iOS App Store that gives me a container to run NativeScript apps within it. Really convenient, again, totally free in the App Store, super convenient way for us to get up and running. And let me bring that up here. Oops. There we go. So I can scan this QR code. I should probably hide that a little bit. So what you're going to see here are my development environment alongside my phone. Now, is this the most gorgeous app you've ever seen or what? No, it is not. But everything you see here is truly native. So what we provide out of the box, it's just some labels on a screen, right? So I'll go into some of this in more detail in a little bit. But effectively, what we get here is a complete development environment that allows me to do things like I can even drag and drop an element onto my canvas here. And when I just hit Command Save to save that, it instantly reloads the app and I see that button there. Again, this is truly native UI, so I'm not doing a full rebuild to get this. It's a really quick iterative development environment. A couple of the things about the playground that are really helpful for me in particular. Now, since I'm like maybe not an Angular expert, or maybe I don't even really know what I'm doing in TypeScript, when I drag and drop that button element on here, you'll notice the on button tap event showed up here. When I go to my view model, you'll see that my on button tap method appeared here as well. So this really helps me to kind of visualize how these apps are structured. Now for me, I don't really know Angular at all, so if I'm going to start a new Angular app, I can actually almost start learning that framework just by playing around with the playground, dragging and dropping elements on here as well. There's a lot more we can throw on our screen here. We can get into data entry elements, all kinds of date pickers. We have action bar, these filtering options, all kinds of data visualization options as well. There's really, it just goes on and on and on. And there's layouts here as well, which I'll talk about in a moment. Also within the playground, there's a Get Started menu here. This is where you can access a variety of tutorials. So we have a bunch of tutorials available for JavaScript, Angular, and Vue as well. So this is all a really great place to get started. We try and make this getting started experience really as friendly as possible. What else can I show with the other thing I'm going to show along with the playground is the NativeScript Marketplace. Now the NativeScript Marketplace is a very, very, very useful place to go for plugins, for instance. So if we want to extend our app into a variety of native device features, head to the Marketplace. There's a variety of app templates available. These are fully featured app templates, kind of providing a turnkey solution for some of these that you can adjust, add on as needed. My favorite part of the marketplace, though, are the sample apps. The sample apps they're not quite app templates. They're smaller pieces of code that you can kind of copy and paste into your app. We provide we're covering a lot of different topics in the sample apps. You can filter it by framework as well. So if you're only getting into Angular apps, for instance, you can filter it by Angular. All of these sample apps also run in the NativeScript Playground. So when I just click on the Playground demo, it's going to open a Playground instance. I can run it on my phone immediately. I can copy and paste that code into my app. Everything here is open source, freely available. So that's my 5-minute spiel on really how to get running quickly as possible without going through those dependencies that you normally have to install. And now that we kind of have a very rough idea of how we get up and running with NativeScript, I did want to kind of look at some of these core concepts that I've been glossing over a little bit here and there. The first one is this idea of the iterative development environment in NativeScript. When we started with NativeScript, we had this feature called Live Sync. Now, Live Sync, what it did, it let you make changes to your app, view those changes on your device without doing a full rebuild. The problem with this is you lost the context of where you are in the app. So you lost the state of the app. It would reset from the home screen. We recently, maybe 6 to 9 months ago, released a feature called Hot Module Replacement, which is from part of the Webpack utility. And Hot Module Replacement gives you that same experience, that same iterative development experience, but provides a stateful reload of your app. So I can be making changes to my UI layer, to my JavaScript, to my CSS, and have the state of my app be persisted, which you can imagine how quickly that's going to help you iterate through issues, especially when you're trying to tweak CSS here and there. So the way that this works with your NativeScript development is that Live Sync is still the default. So if you do TNS run, which is going to actually run the app on an emulator or a connected device, it's going to use Live Sync still. We're going to transition this soon to having Hot Module Replacement be the default. But as of today, it's still TNS run. If you want to use Hot Module Replacement, just add that HMR flag to your command. Now to get into more of those core concepts, again, the UI controls that we provide are native modules, right? They are cross-platform abstractions. When I drag and drop that button, or the switch in this case, to my canvas, the switch tag, it creates a native iOS switch, a native Android switch. You don't have to worry about anything other than the switch tag. We support a variety of UI widgets, as you can see right here. Basically anything that's provided on iOS and Android platforms, you can do with NativeScript. And again, just to focus on the NativeScript UI components of this, these are native behaviors, native performance out of the box, really getting that true parity with native. Now I put this up here as an example of a to-do list app. We're going to look at this and kind of deconstruct some parts of this to kind of help gel where we're headed here. We start at the top, and this is a label, a NativeScript label, right? It's a styled label, obviously. It's bigger, it's colored differently. We also have a text field, so a text input field, if you will. And we have a list view that's going to be bound to an array of items. And we have a segmented bar at the bottom that allows us to filter our items in our list. Now that we know something about UI elements, we also need to lay these elements out on our canvas some way. And there's a variety of ways of doing this. Since there's no concept of divs in NativeScript land, we provide a variety of ways for you to really effectively lay out your UI in a variety of different ways. So first, we have the absolute layouts. This allows us to provide top left coordinates to our elements and put them anywhere we want on the canvas. We also have a dock layout, so this allows us to reference UI elements in the top, left, right, bottom, or center of our native UI canvas. We have a grid, which is effectively an HTML table, if you will. We have a stack layout, lets you arrange items horizontally or vertically. And we have a wrap layout that simply wraps elements around each other. And we also, if you're a Flexbox person on the web, we also do support Flexbox in NativeScript. Now, the real power of these layouts is not necessarily the different ones, but the fact that you can nest different layouts inside of each other. So commonly, you'll take a grid layout, and then within a grid layout, in one of the cells, if you will, you'll have a stack layout, and so on. You can nest them any which way you want. It's really pretty effective. So when we look at this example, this whole app here is effectively a stack layout, right? We have these elements on top of each other. Within this stack layout, we have a grid layout that kind of separates a label and a text field. We also could do a stack layout, but stack those horizontally instead of vertically. We have a grid layout at the bottom with a variety of controls in here as well. So this kind of gives you an example of sort of how we nest UI elements inside of layouts, which are nested inside of other layouts. Now, I do want to touch on platform-specific development really quickly, because even though I've been kind of spouting this idea of writing once and building for multiple platforms, you can also develop your app for one platform specifically, depending on the feature you want to expose. So what I mean by this is that you can have your file structure can be focused on either Android or iOS. So let's say you had a certain view or page of your app that you just wanted to show up on iOS or Android. You could say filename.android.xml, or maybe the CSS is going to be different. So filename.android.css, that is only going to then show up on that Android platform. Within your markup layer itself, you can actually have Android and iOS tags. So you can make chunks of code only available, chunks of markup only available on one platform or another. You can even have individual attributes of UI elements exposed to one platform or another. This is a good example here. I may want different CSS classes applied to my label just by prepending that Android : or iOS : Again, we are very focused about writing once by default, but we do provide kind of these outlets to let you develop for individual platform capabilities when you need them. And just to mention too, again, focusing on the styling with CSS, we love CSS. We've been using it for years. We're all experts in CSS. The thing we need to know about NativeScript and CSS is that we do not support the entire web spec for CSS. We are limited to a certain number of properties. These are always expanding, but we're being very careful with what we add. We don't want to create the mess that exists on the web. So pretty much everything you should need is going to be here. I know we are actively looking at adding things like box shadow as well to get some of those more fancier UI features in CSS as well. When it comes to CSS, we also support the selectors that you've been using on the web. So you can select by element type, by class name, by ID as well. That all works exactly the same way it works on the web. While we're on the topic of UI, I did want to do a quick plug for Progress NativeScript UI. These are completely free UI controls available on the website you see here, on the page you see here. We provide controls like charting and graphing, a data form to automatically create a data form from a data source, calendar, these gauges, there's an autocomplete text box, there's a couple other things I'm blanking on, but there's a lot of really good plug and play options here as well if you want to add some easy functionality to your app. Briefly, I know people always ask about debugging. We all write bug-free code, but I know, those of us who don't probably need to know this, but you can debug by alert. So back in 1999, when I was starting my development, I would, throw variables in an alert. You can still do that today, believe it or not. You can debug by the console, so you can output variables to the console log like you've been doing for years with JavaScript development. You can also debug with the developer tools. So we support a subset of the tabs available in the Chrome Dev Tools and the Safari Web Inspector as well. You can also use, if you're using Visual Studio Code, it should put WebStorm up here as well. You can use those debuggers available in those IDEs as you see fit. And just to look at our DevTools support, like I mentioned, we don't have support for all the tabs right now. We're looking at adding on to these as time goes on. Especially the big one for me that we're missing right now is the Styles tab, so I can start tweaking CSS in my app. I know the team is actively looking into this, so hopefully we'll have support for that pretty darn soon. Now, as we wrap up here, I want to just kind of cover the easy ways we have to start. And there are really, when it comes down to it, 3 really easy ways to get up and running. The first is the playground that I really briefly showed off. Everything totally web-based and really easy to get started. You can deploy to a physical iOS or Android device, as I did kind of here. You can debug through the console if you want. The limitation of the playground is that you can't use any plugin you want to. We do provide a subset of plugins that you can use, but when you get into really serious app development, you can always download your project from the playground and use the command line interface from there. So the CLI, this is where the real power of NativeScript comes through. It's compatible with Windows, Mac, Linux. Really, you know, it's a step up because it allows you 100% access to the entire NativeScript platform, if you will. We do have an integration with VS Code and WebStorm as well, so via some plugins that you can find there. And if you're on Windows, I'm always asked this question, if you're on Windows and you want to develop for iOS, you can use a free product of ours called NativeScript Sidekick. It lets you handle cloud builds. So we build in the cloud and then deploy it to your app. So if I had a Windows machine here, I could run Sidekick. It's going to build my app in the cloud. I can develop it locally. I can make a change to my app here. It'll sync up with the cloud. It's a pretty amazing experience if you're on Windows. Finally, I wanted to mention Kinvey Studio. We really briefly covered this in the keynote. It's another really great way to show off how we're using NativeScript, but also a really easy way to get started with NativeScript. We're a lot more focused on drag and dropping UI components onto a canvas, as well as providing some pre-wired views that you saw in the keynote as well. So there's a lot of sessions on Kinvey Studio later on that we can see. Is there anything else we need to cover?
Is there anything else we should talk about?
Probably not.
No, probably not. He nailed it there. I did, as we finished up here, I wanted to mention our community, because as a free and open source project, we are, you know, always trying to help our community out. And they've done some amazing things. They've written entire books for us that you can check out. Actually, the NativeScript book on the left there, that's available for free on the nativescript.org website. They've also created sites like nativescripting.com. If you're a video learner, I highly recommend checking out nativescripting.com. In order to get support, we have like 11,000 plus people on Slack. We're also very focused on Stack Overflow, so if you have questions, I highly recommend going one of those two routes. And if you feel anything like me, this is kind of your state of mind right now, but I do want to leave you with kind of our elevator pitch, and that is that NativeScript really is an open source framework for building these truly native mobile app experiences with JavaScript. You're using your web skills like Angular, Vue, CSS, and you're getting truly native UI and performance out of the box for both iOS and Android. And let's see how we did today.
Ellie, what would you choose between NativeScript and React Native?
She said NativeScript, so we won. And it was without prompting, too. It was amazing. So everything you need is on nativescript.org. If you want to check out Kinvey Studio, it's available on the Progress site at progress/Kinvey/studio. And that's it. Thank you all very much for attending.